All right, welcome everybody. Thank you so much for joining today for Vegetated Roof Essentials, Navigating Coordination, Milestones, and Challenges. It's presented by Richard Kile from Siplast, and we've also got Reed Kunkel on here today. He'll be helping out with answering some questions. So please feel free to submit any questions throughout today's presentation to the Q&A. We'll be sure to keep an eye on those and be able to answer some throughout today's live presentation. And if your question doesn't get answered today, we will have a record of it so that it can be followed up on after the event. My name is Bo. I'm here with Acelab. We are helping out with hosting today's event. A few quick housekeeping items from me, and then I'm going to hand it off to my colleague Helen, our Director of Architectural Experience, to give a quick little intro about Acelab while folks are joining, and then we'll go ahead and get started with today's CEU course. So first off, we did ask for AIA numbers upon registration. Just in case you're worried you didn't submit it there, I'm going to send over a form in the chat, so you can feel free to add your AIA number there as well. There we go. So you should have that now. Other than that, just want to encourage folks to please ask as many questions as you'd like. We love engagement from the audience. And without further ado, Rick, would you mind if Helen takes over screen share for a moment to give a quick little Acelab intro, show folks how to connect with you guys on Acelab after today's event, and then we'll go ahead and get started with today's CEU approved course.
Absolutely.
Awesome. Thank you. Hey, everyone. I'm Helen. As Bo mentioned, I'm the Director of Architect Experience. My job here is to basically make sure y'all have a wonderful time searching and finding everything. Looks like my screen is still loading. Is that true? Is it not up yet?
Should be on there.
Okay, cool. And so that's my ask to y'all is as you're going through Acelab, if there's anything that you have questions on, you're loving, you're not loving, we want to hear about it. The way you can get in touch with us is through this live chat. There's no AI bots in that. It's myself and two other team members, one of them being Bo. And so we answer those. And I wanted to talk about one other way to use that live chat. So Acelab's a great spot to find and search for your products, save them, kind of create records, libraries, and so on of all those products that you want to use. But if you ever get stuck on something or have a question, you can always reach out to us here. We have a team of experts who do this day in and day out while y'all manage all the other things that you do. And so feel free to reach out here. Here's an example of someone who did. They were looking for aluminum windows, commercial project. They need to meet a specific solar heat gain coefficient. They were working with their mechanical team kind of right then and there on some modeling. So we were able to make some product recommendations for them, including how to spec the glazing packages for some of these manufacturers. So this is what this looks like. Gives them one place, all this information that meets their requirements, and then some additional info on what might be the best choice given their project. So this is what a short list looks like in Acelab. And with that, I'm going to jump over one last spot, talk about how you can get in touch with folks that you want to talk to about certain things. So you come up here into the search bar, select brands, and then you can see we've got these folks here. Scrolling on down, you can contact them directly. And then also if you scroll on down, you can see all of the different products across all the different categories each manufacturer has. So that's how you get in touch with us. It's also how you get in touch with them. And if y'all have any questions, want to do some training for your team, I'd love to chat with you a bit more. All right, that's it from me.
Awesome. Thank you, Helen. All right. So Rick, it's over to you. Whenever you're ready, you can feel free to get started with today's course.
Great. Thanks, Bo. Thanks, Helen. I'll do the obligatory. Can you see my screen before I get rolling? All right.
Great.
Wonderful. Thank you again for the introduction. My name is Rick Kile. I'm the Director of Green and Amenity Business for Siplast. So I focus on our vegetated roof and overburden programs. And joining us today is Reed Kunkel. Reed, you want to say hey?
Sure. Reed Kunkel. I'm our product development manager for our SBS or asphaltic lines over at Siplast, and so I handle anything asphaltic in North America.
Thanks, Reed. So as Bo and Helen both mentioned, please type any questions you might have in the chat. Reed will do his best to censor those over to us during the presentation and answer those as we go. We'll certainly get on to answering them at the end as well. So thanks again for joining us. Let's get rolling. Just a statement about the learning credits. I think Bo hit this pretty well. Move on. Course description. I'm presuming a lot of you read this already, so we can move on from here. Our learning objectives. This is lagging a bit. Our learning objectives, we're going to learn about the benefits of vegetated roofing today. We're going to understand the various roofing and waterproofing components that can be coupled in those technologies and how they work together with vegetated roofing assemblies. We're going to differentiate between the different types of vegetated roofing assemblies, what components help comprise those. And then we're going to, really the meat of the program here, learn about some of the keys to successful coordination of vegetated roofs. So, and when we talk about vegetated roofs, there's some obvious benefits that come to mind, you know, whether they're social or economic or you know, certainly environmental. But you know, they can do a lot for not just a feel-good story. There's a lot of technical benefits, and so we're gonna talk about some of those. The most important environmental benefit, or the most significant, is the reduction of the urban heat island effect. So I'm presuming most people on the call know what the urban heat island effect, but for maybe those that don't, in our urban areas, we have much less pervious space, much higher concentration of built environment, and so that drives our ambient air temperature up, certainly compared to more surrounding rural areas. This has a negative effect not only on the way that the urban area might feel to us, especially in summer and warmer months, but also can have a negative effect on our health, negative effect on the ecosystem around us. It certainly makes it a less comfortable place to be. Another environmental benefit is, yeah.
Real quick, just on, I mean, the urban heat island effect has been kind of more focused on in the roofing community over the last 10, 15 years, and with Cool Roof Rating Council, and some manufacturers have like depolluting granules that take nitric oxide out of the air. Like, how would you compare a vegetated roof's effect on the urban heat island effect with some of those roofing technologies?
Yeah, so it's a great question. I think you know, the most prevalent of those is cool roof technology or white roofs. Depolluting is maybe a little less known, but certainly a great technology as well. I would say vegetated roofs are a different tool, and I would call the attention to the temperature at the surface for a vegetated roof. So temperature at the surface of an extensive vegetated roof, so something planted with sedums, which we'll review in a little bit, on a hot summer day is in the low 80s, like 82, 85 degrees. That's largely due just plants. We think of evapotranspiration, the processes involved there. It's much cooler. A dark colored roof on the same summer day is 130, 140 degrees. And so there's a pretty big temperature swing there in terms of the temperature at surface. Cool roofs do a good job of reflecting some of that heat, but then that light, but that then stays in the atmosphere. So it's like a white roof or a cool roof is going to be, I think I've seen, you know, 100, 110, 115 maybe on that hot summer day. That's still 20 degrees north of the surface of a vegetated roof. So different tool, different application. Ultimately, the end result is a benefit to the environment regardless of the technology, but there are some significant differences. Environmental benefits, you know, we talk about habitat recreation. Certainly, birds, butterflies, bees, pollinators, really critical to healthy ecosystems. And in our built environments, these opportunities and habitat for these animals and insects certainly is less. It's reduced. So adding vegetated roofs provides space, provides opportunity for a healthy ecosystem. There's a picture on there of even a gray fox. So that's more of a podium on structure type of application, but really it's not just limited to birds and bees. Improved air quality. Plants help capture airborne pollutants, atmospheric deposition, and they help filter noxious gases. So again, through that evapotranspiration, vegetated roofs can act as a carbon sink. So moving on to economic benefits, the environmental benefits are great. They're significant. They're things that we should be doing as designers and incorporating into our projects. But how do we justify it from an economic standpoint? The single greatest benefit to an owner is the increased roof life expectancy. So the number one degrader of roof membranes is UV degradation. And so by putting a vegetated roof over the top of our membrane and limiting the effect of UV degradation and also physical damage. We're adding additional layers or protection for that roof membrane. We are extending the lifespan of that membrane. And so by doing that, the owner has to re-roof that much less sooner. And as a result, they might get 2 to 3 times more lifespan out of their membrane when it's in a buried application. Re-roofing is extremely expensive when you consider that maybe the tower cranes, the construction logistical equipment that was on site during the initial construction is long gone, and trying to get those materials to the roof, get the labor force on the roof, get the old roof materials off, the new materials back onto the roof, and not to mention potential downtime for the structure. So the longer an owner can put that off, the better. And so a vegetated roof can be a great way to help extend the life expectancy of that membrane. Green roofs also reduce the daily energy demand. We think about the difference between that 130, 140 degrees and 82, 85 degrees. That's a significant change in temperature, and that because we're reducing the fluctuation of the temperature at the membrane at the roof assembly level, that's taxing our heating and our cooling much less than having those larger temperature swings.
Rick?
Yes.
Sorry, a couple questions. One on the last slide, just extended life. How does the extended lifespan of the roof affect the warranty? My expectations would be that it's going to be dependent on manufacturer, but most of the time it's not going to affect the warranty from a manufacturer's perspective. But I don't know if you have a different answer for that.
Yeah, I don't think, just from a roofing manufacturer's perspective, I don't think roofing manufacturers look at it as we're putting a vegetated roof over our membrane, so we're going to extend the life or the guarantee period or the term. That really boils down to how is that being specified as a membrane specifier, and what term are you looking for? I think most common in the industry, we're looking at 20, 25 years for a membrane guaranteed.
And then when it comes time to re-roof, how much more complicated does it get when you have to remove green roofing components and replace them during the re-roofing process?
Yeah, it does become, it definitely adds another layer of complexity. We have to think about point loads where we might be able to store those materials while we're servicing a potential another area of the roof. It's certainly just like I've been in the vegetated roof industry for a little over 10 years now, and I don't think I've worked on 2 projects that are the same. I would imagine that certainly translates to when it comes time to re-roof a vegetated roof as well, how that's handled logistically and the challenges that might be involved.
And then the last one that came in, which I think you're going to answer later on in this as well, but would urban gardening be compatible with vegetated roofing?
Yeah, absolutely. And I presume maybe there'll be a follow-up question here. I presume we're talking about like urban agriculture or farming, but that's certainly something where we're seeing an extended increase in interest and more projects, whether they're public projects, academic projects, certainly have a really strong interest in urban agriculture. It becomes part of the curriculum. There are big public centers like Levi Stadium that has converted an extensive roof to an agricultural roof and services commissaries in the stadium. So really farm to table at its finest. Thank you, Reed, for relaying those. So to get back to the insulation value and the potential reduction in energy usage. One of the most popular questions we get is actually growing media. Can the vegetated roof assembly count towards my insulation value requirement for the project? And unfortunately, it can't, because the insulation value of the growing media is going to fluctuate depending on the moisture content within the media. Same with the drainage and water retention layers. That said, there's definitely an insulation value benefit to it. And again, if we go back to that temperature at surface change, you're certainly going to see a significant benefit and impact on your energy usage. The most significant driver of vegetated roofs in the U.S. and I think the world now is stormwater management and utilizing vegetated roofs and vegetated roof technology to manage stormwater. And traditional extensive thinner assembly vegetated roofs typically they manage stormwater via retention. So retention is holding on to water within the water-filled capacity of the growing media, and then the plants use it for obviously use it in photosynthesis, and then it's released via evapotranspiration. And it can also be stored within drainage and water retention layers, and that's not released off of the roof. Stormwater detention is holding water on the roof for a predetermined amount of time and slowly releasing it. Most stormwater management requirements across the country are detention-based requirements. And if you have trouble remembering which is which, I think about like sending your kid to school and they get in trouble, and and the school has them in detention, and then but they do send them back. So just like the water, we find a place to park it for a while, and then the roof releases it off. So there are additional tools that we can incorporate, we'll touch on later, that allow us to transform retention extensive roofs into detention-based roofs. And really, it helps eliminate some of the issues we see in the picture there. That's just a small rain event in Chicago, and you can see there that the municipal storm system is overloaded because we have too much impervious surface. And so by slowing the water from rooftops to the drains, so it's not all hitting it at once, we eliminate some of this flooding. So Reed, this is where I get to kick it over to you, and you can talk to us about thermal and moisture protection.
Sure. So let's walk through some common roofing and waterproofing technologies. The first up, you can go to the next slide. First up, we have thermoplastic membranes. This category contains several different technologies. So there's thermoplastic polyolefin, which is commonly known as TPO. There's polyvinyl chloride, PVC, and then a little smaller subset of that is ketone ethylene ester, or KE. They each have differentiators between them, but have a very similar application style. So for the purposes of this, we'll just kind of talk to them as a lump. Thermoplastics are manufactured to be watertight from the factory. They typically come in wider sheets of 5 or 10 feet, which helps with speed of application, as well as reducing seams. The seams are heat welded and provide a somewhat impenetrable lap when done properly. There are some hybrid applications coming out and more folks looking at that, but traditionally thermoplastics are single ply applications, and they don't necessarily allow for a multi-layer flashing detail that would be more commonly associated with what we're trying to achieve in a waterproofing assembly, especially transitions and penetrations. Even though the seams are heat welded, they're relatively narrow, and being a single ply system, even a minor breach can allow for some moisture migration beneath the system, even when it's a fully adhered system. So some things to think about. Next slide. We have hot rubberized asphalt, which is a pretty common material historically for vegetated roof systems. HRA systems are pretty simple to understand and even apply, and they allow for creating a monolithic membrane that can cover a large surface that's obviously seamless. Because HRA membranes are heat applied or hot applied, the base asphalt component needs to be heated up to 380 or 400 degrees with a kettle on site, and so because of that, it becomes a little less desirable for obvious safety concerns. And then there's less skilled labor that's interested in doing this type of install today. Because the material is soft following application, it can be susceptible to some mechanical damage unless it's properly protected. It needs to be covered with a protection course, and even then, it still must be covered with the vegetated or the final assembly to protect it from long-term UV exposure. Next slide.
What's the typical exposure time for an HRA?
I mean, it's going to depend on the cover board, but usually you're looking at around a month.
Okay. So something to keep in mind in sequencing, which we'll also talk about later.
Polymethyl methacrylate, or PMMA. It's a liquid applied membrane. It comes to the job in buckets that's then catalyzed and applied. Liquid applied resin is combined with a polyester fleece, and then it's used to, or it creates a membrane that can be applied both horizontally and vertically, and can conform to almost an unlimited amount of conditions. It's one of the reasons that it initially came to market as a detail flashing membrane, because of its utility in that method. Known for its rapid 45-minute cure time, which is pretty incredible. That's one of the primary attributes of PMMA. Areas can be completed and ready for use potentially even in the same day. It's also compatible with a variety of different substrates, so asphalt, concrete, brick, steel. It'll stick to a lot of different things, even certain thermoplastic formulations as well. It's suitable for a lot of applications, but I would say one drawback, you're looking at a short pot life. It is catalyzed, and so it's got to be applied pretty quickly upon mixing it, which can create some waste if it's not properly if you're not properly judging how much is needed, or how well the conditions are for application. It's also somewhat challenged in hot temperatures, so it likes colder temperatures for application a little bit better. So if it's above 100 degrees out, or if the surface temperature is above 110 degrees, that can create some challenges. And applicators got to be more careful with storage and handling in order to get a proper finished product. Generally speaking, it's on the higher end of cost as well, so it's got some cost implications there versus some other traditional products, but it creates a pretty bulletproof assembly underneath a vegetated roof.
Yeah, I would agree with that, and I really just wanted to reiterate the compatibility with other materials. You see it used as flashing material with hot rubber a lot, or SBS membranes, because it is UV stable, and it can be a great solution for very complex penetration and flashing details, and provide a very robust sound solution there.
Finally, we come to SBS mod bit, which I, being an asphaltic product manager, am a little partial to.
You're glowing.
Mod bit sheets are thick pre-manufactured waterproofing plies. They're applied independently in a multi-layered format. It creates a redundant configuration. It's pretty conservative. Gives you double protection at least. Because each layer's independently applied, it allows for phase construction, which can help both with drying in faster, as well as just, kind of a halfway point in the process where you've got a dry building and you've got the ability to have other trades come in, do their business, and then we can put down the finisher cap sheet before the vegetated assembly comes in. Predominantly in waterproofing applications, SBS is applied by torch, but it can also be applied with cold adhesive, hot mopping, or there's even self-adhesive applications as well. Some drawbacks: multi-layered approach and application method does not necessarily, it's not a quick installation compared to some other installations. Certainly putting down one ply versus two plies can change your time for application. Torching is a growing concern for building owners and consultants in certain geographies and certain building types or construction types, and so it is something to always keep in mind when a flameless application is called for. Typically, SBS is put down with a torch.
Next.
And then I think the next is it's insulation. So I'll flip it back to you.
All right. So insulation is really going to depend on the type of membrane and then the membrane configuration. Polyiso is used in conventional membrane. So a lot of times with most commonly coupled with single ply membranes, but also SBS can be coupled with SBS or PMMA. XPS insulation is a closed cell insulation that can be used in inverted applications with an R value of 5 per inch. So slightly less than that of polyiso. And so in an inverted situation, you have a membrane typically down on the substrate, and then you have your extruded polystyrene over the top. Vacuum insulated panels are a newer technology. They've been around in terms of, I shouldn't say newer technology. The technology has been around in the form of usually like appliance insulation for a long period of time. It's made its way to the roof now. It does tend to be a pretty high price point, but is a really neat tool in that they provide an R value of 28 to 30 an inch per inch of thickness. So when we think about re-roofing and retrofit projects and an increase in R value from the time that the project was originally built to the time it's going to be installed or at the time that it's being re-roofed, we might have gone from 3-4 inches of insulation to 8 inches of insulation to meet our R value requirement. A vacuum insulated panel is a great way to keep that total assembly profile shallow and maybe eliminate the need to elevate building mechanicals or elevate roof parapets, which can have a significant cost associated with them as well. A little bit of a drawback is that they do, when they're punctured, then the insulation value is essentially nil. So they can be a little fragile. They're a little more difficult to work with on site, but a great technology nonetheless. And then EPS is most commonly utilized as lightweight fill within vegetated roof assemblies. It does have an R value associated with it as well, slightly higher water retention or absorption than an extruded polystyrene, but used in lightweight fill applications most commonly.
Hey, Rick, there's a question about a mineral wool. Is mineral wool utilized?
Yeah, so in the vegetated roof world, we use a mineral wool. Most commonly, it's a needle punch product, and we'll talk about it. In terms of insulation, I'm most familiar with the rock wool as a board that has a binder in it. And so from that perspective, I think it's most commonly used in wall applications, not used in horizontal on the roof. But certainly another type of insulation that's common in the marketplace and utilized within the building envelope. So lightweight insulating concrete's another potential solution. It can be a great way to get a sloped lightweight topping slab over a zero slope deck and provide insulation within that slope topping. And it has a great sustainability story as well. It's a stable R value over time, and it also has acoustical properties. So lightweight insulating concrete can be a great solution on a podium to help incorporate slope into the assembly beneath the membrane.
There was a question about compressive strength in a high load environment. What's best for compressive strength?
It really depends on the compressive strength. So is that, you specify whether or not that's specifically related to lightweight insulating concrete or?
No, I think it was, it came in during the general conversation about insulation.
Yeah, so there are different compressive strengths available for polyiso, for the cover board that might be associated with the polyiso. If it's an extruded, there's 25, 40, 60, 100 PSI. 25 is typically a roofing application, 40 we'd use in vegetated roofs, 60 we'd use underneath pedestal pavers, and 100 you're using under drive aisle. So it really just depends on the application and what density. Geofoam or EPS has a similar story with regards to different compressive strengths depending on the application. So that's a project by project basis recommendation. So moving on to vegetated roof components, and we're about 30 minutes in, so we're gonna zoom through this a little bit because I want to make sure we leave plenty of time at the end for the coordination part. But layered vegetated roof assemblies, you can see here based on these renderings, there's not a lot of stuff that's different, starting from the drainage and water retention layer on down. So we have a substrate, we have a membrane. These graphics are showing uninsulated condition. But usually we would have some type of insulation, either conventional beneath the membrane, we'd have polyiso, or inverted, we'd have extruded over the top. You know, we have a drainage and water retention component that might be one of a couple of different technologies depending on the project needs. And then we have a growing media, and that growing media is either an extensive, an intensive, a semi-intensive, depending on the application and what's being planted and what's being utilized. Those blends will vary, and then the type of plant material. But you can see there's a lot of commonalities between these assemblies when they're layered assemblies. Root barriers are obviously they provide root resistance, and it's important to be able to coordinate with the membrane manufacturer. Do they require a root barrier over top of the membrane? Some membrane technologies do not, some membrane manufacturers do not, others do. I would say generally with at Siplast, we don't require an extra root barrier over top of our PMMA. It's optional, but we do require a root barrier over our asphaltic products. So really just depends, important to coordinate that aspect. Most root barriers are an HDPE sheet in some sort of varying thickness depending on the application. And so there's a 20 mil for an extensive, so a thinner gauge for an extensive roof with less aggressive rooting plant material, thicker, more robust sheets for more intensive plant material, trees, aggressive rooting plants. These are typically either overlapped with some sort of root barrier tape, or they're heat welded. And I actually prefer the heat welding application. I think plant selection, always keep in mind plant selection when you're on the roof. Bamboo might seem really cool, but it has extremely aggressive roots. There are other plants out there with aggressive roots as well. You can usually find a suitable substitution that will meet the same or a similar design intent without compromising the waterproofing or the structure. So just keep that in mind. Filter fabrics are essential in the vegetated roof application or assembly because they help contain the growing media. So this helps prevent particles within the growing media or particles that might accumulate from the surrounding environment from migrating throughout the assembly and clogging other layers, clogging roof drains, potentially leading to ponding, which creates unintended point loads and could create a catastrophic condition. So we obviously don't want that. We want to keep the media in place where we intend it to be. And so filter fabric helps do that. Drainage and water retention layers. I mentioned earlier, there's a number of different technologies, and there's a number of ways that this can be approached depending on what the project requires. This is one of the biggest points of coordination when you're working with a vegetated roof manufacturer to understand, you know, what are we looking to achieve? What's our design intent? And then what are our thresholds, either weight or height tolerances? And then, you know, what is going to give us the best solution in terms of maybe most water retention, or what's the most practical approach here. There's a couple different options or technologies, I would say. One is an inverted dimple style mat, as shown up there on the upper right hand corner. And so if you're familiar with the dimple style drain mat, these are essentially flipped over, and they do three things. They provide excellent drainage. They hold water in the inverted cups for long-term use by the plant material. And then there are actually, it might be a little tough to see, but there are actually holes punched in the flat horizontal part that help introduce air and oxygen into the bottom of the media profile. This helps prevent an anaerobic condition from occurring at the bottom of the media profile. It's essential to plant health. As many projects as you see, vegetated roof projects as you see that are underwatered, and it might die of thirst, we see a lot that are where maybe there's flooding and the plants actually drown because there's not good oxygen or air at the bottom of the media profile, creates an anaerobic condition. Mineral wool, that question came in earlier. I'm glad it did. This is obviously looks different than the mineral wool used for insulation. This is a horticultural grade mineral wool, and it has very robust water retention properties to it. And so this can be a great tool for stormwater management with regards to retention. It can also be coupled with an entangled drain mat, or it should be coupled with an entangled drain mat to provide that drainage. But it can also help make really thin extensive assemblies or extensive assemblies in general on arid climates much more viable solutions. It can also act as a capillary mat. There are other options out there. There are drainage and water retention panels that, again, will provide drainage. They'll provide aeration and water retention as well. So really a lot of solutions there. There's a number of reasons why we use engineered growing media on the roof. It's typically lighter weight than a comparable topsoil in a given area. Here in Southern California, a sandy loam topsoil, which is most common, weighs about 120 pounds a cubic foot when fully saturated. Conversely, or comparably, an engineered growing media is going to weigh 85 pounds a cubic foot fully saturated. So a pretty significant reduction in weight. But just as much as the weight, we also need dependable performance. So an engineered growing media has components that we know have a specific performance. The output of the blend when it's put together is dependable. We want a certain amount of air-filled capacity. We want a certain amount of water holding capacity. We want to ensure that there's good hydraulic conductivity. Hydraulic conductivity is the rate at which the water will flow through the media. And if we don't have good hydraulic conductivity, say we use a sandy loam topsoil that only drains 1 inch per hour, we get a big flood event. We could end up with ponding on the roof again, unintended point loads. Water's really heavy. Engineered growing medias are also typically lower in silt and clay particle sizes. This is by design. Again, we need some of those to help with help irrigation be more effective, help the plants be more successful, but we don't want too high silt and clay particle sizes. Those are what have a tendency to migrate throughout the assembly, clog our filtration, clog our drainage layers. So we want to make sure that those are limited in some capacity.
Hey, Rick.
Yep.
A couple questions probably that make sense to answer here. So one, you were talking about the weight differential between engineered growing media and other. There was a question a while back about kind of what is the added weight of vegetated roof on a roof dead load, and I'm sure that that's a big range, but yeah, I don't know if you can answer that.
Yeah, we'll get into the specific assemblies here next after we review the components, but it's not, when we look at vegetated roofing, I don't like to look at it as here's a vegetated roof. It's a finite product, right? We really have the ability to tailor these assemblies to the project. And so it depends on where the project is, what they're looking to plant, what's the project objective, what's the programming, and then how do we tailor that assembly to the project to fit within those thresholds. So we'll give some ranges though as we go through extensive, intensive, semi-intensive.
There was another question about how do plant roots access retained water from the dimple drainage layer?
So there's a filter fabric to help contain the growing media, but the plant roots are actually able to get through that filtration layer.
Thank you.
All right. Engineered growing media, again, it's usually comprised of 3 components: a pumice, an expanded shale, a lava. Those are lightweight aggregates. Those were going to vary depending on the region of the country that you're in. there's usually a compost component that's providing our nutrients, and then a fine aggregate in the form of sand. And these are usually blended in different ratios for depending on the application. So extensive usually is a little more aggregate based. Semi-intensive usually has a little bit higher sand component. Intensive has a little more organic content to it. Extensive vegetation, vegetated roof industry in general kind of stops at extensive. So sedums and succulents, herbaceous perennials, small to medium-sized ornamental grasses, things that are manageable. A couple of different options, whether it's a plug, a small container plant, or a sedum mat to quickly vegetate. And then accessories. How are we transitioning from vegetated areas to non-vegetated areas or vegetated free zones, potentially paver areas? And then just a note on irrigation. I think irrigation on every vegetated roof is really good insurance for what can be a decent investment by the owner. So irrigation, even if it's turned off for 2/3 of the year, since we're in a time of climate volatility, I think can go a long way to certainly during the establishment period, but then beyond to extend the life of the vegetated roof. So we'll talk about the different types of assemblies. Again, this is extensive. These are your municipality mandated. We need to comply with 9294, or we're not going to be. It's not an occupiable roof. These are your thinner assemblies, your performance-based, a lot of times used for stormwater management. And so your media profile is going to be somewhere in the range of 3 to 8 inches. So your total assembly weight is going to be 25 pounds a square foot, maybe at the thinnest, to 60 pounds, somewhere in that range. It's almost always planted with, again, those non-woody plants, so herbaceous perennials, small to medium-sized ornamental grasses, sedums, and succulents. And you'd spec a thinner root barrier with that if required. So just an example of some extensive projects. Semi-intensive is most commonly lawn, but it also, I guess, prairie grass, prairie style falls into this because of the depth of media ranges from 8 to 12 inches or so. As a result, with growing media being the heaviest component within the assembly, that weight range is going to creep up. That's for a couple of reasons. One, those prairie style grasses and forbs, or that turf grass, those are all pretty water intensive types of plants. And so we need a deeper media profile to help provide ample opportunity for water storage for use of the plant material. Turf grass is also an active space. So most commonly, if you're going to plant turf grass, you're going to probably have people on it. We need a deeper media profile for stability purposes. This is called urban agriculture, comprehensive urban farming, rooftop farming. Again, the components are pretty similar here. This media mix is probably going to be the most different. Because it's going to be a media compared with an intensive, extensive, or semi-intensive that is going to have a pretty stagnant, stable media profile. Agriculture is going to be consistently worked. So this is going to have a much higher organic content to it. We just need to make sure that the performance here again doesn't have too much silt and clay particle size, that it has some stability to it, and that it fits within the project thresholds. These media profiles are usually 10, 12 inches deep, just because you are going to have it regularly maintained and worked as a productive roof. So that's a Brooklyn Grange project in New York. A great urban farming example. And then intensive, this is kind of range everything from amenity decks all the way through parks on podium, large landscape on podium, and kind of everything in between, everything from those perennials to those large mature trees, deeper media profiles to cater to that wider range of plant material. And we just want to make sure that we're providing proper root protection, proper drainage with this.
Rick, got a few different questions that have come in. One was regarding the drainage mats. How do you prevent bacterial growth in the composite drainage cupped mat?
That's a good question, and I don't have an answer for it. But if we write in, I'm happy to. That person provides a contact. I'd be happy to follow up.
Okay.
I haven't. I would say in any forensic work, I haven't seen any kind of exorbitant bacterial growth within the drainage mats.
Do potential irrigation requirements change depending on growing medium depth?
Yes. There's a number of factors there, or variables. One's going to be where's the project located? Another one's what's the type of plant material? And then what's the media depth? If we have, in any case, if we have a deeper media depth, we're going to likely reduce our irrigation requirement.
And then in the transition from vegetative substrate to another material like pavers or non-vegetative flooring, what is the overlap requirements for waterproofing?
So that really depends on the technology and the substrate and how we handle that transition. Do we need to incorporate a curb? In most cases, I think it's because they are still the same horizontal plane, and we do tend to see the same membrane technologies, be it SBS, PMMA, or hot rubber, specified beneath both pedestal pavers and vegetated roofs. So I think in an ideal world, assuming that the substrate's is similar, that you're keeping the same membrane technology continuous beneath both applications.
And then when would IRMA roofs be used versus standard roofing applications?
Again, that kind of goes back to a substrate and type of construction question. So we see IRMAs, I think, most commonly in commercial construction with concrete decks. We see that more centralized in major urban areas, whereas when we get to less dense areas, it's we maybe more metal deck, coverboard type of work, but it just depends on the project, really. I think that a case could be made that in any kind of vegetated roof application, that an IRMA roof is, or an inverted assembly, might be preferable because you are incorporating additional layers that are going to protect that membrane from the overburden. And so you're reducing opportunities for physical damage as that roof is maintained over its lifespan. Cool. So know about modules. Modules can be a good solution for a project. They typically deliver to a site filled with growing media, fully planted. So it's a good way to quickly vegetate a roof. There are some limitations in terms of design intent, in terms of media depth, perhaps planting flexibility depending on the manufacturer. And you do have some limitations with share of moisture and nutrients depending on what type of module it is. So obviously if we have sidewalls, we don't have the ability to share moisture and nutrients and establish the plant material maybe as well as we would have, but it can provide logistically a great solution to vegetate a roof that might be really challenging to get materials onto. Depending on the manufacturer, you have maybe a number of different depths available. And it's always good to coordinate the layers beneath the module. So at Siplast, if it's over an asphaltic membrane, we require a root barrier and then a filter fabric beneath the module. That might not be the case over a single ply membrane, or we wouldn't require a root barrier over PMMA, but it's always good to work with the manufacturer to understand what's required. So stormwater management assemblies, again, there's our friends retention and detention. This slide is basically there to tell you that there's a number of tools to help meet the project requirement. And so one of those tools is a purple roof concept. This is great in that it takes, again, those extensive roofs that are used or that inherently have more retention-based stormwater management properties and make them into detention-based tools, which is really where most municipalities require stormwater. Blue roofs, similarly, provide opportunities to park water. Blue roofs are, create the space to park the water, and then the flow off of the roof is contained or controlled at the drain. And so the center picture there is a flow control drain. This releases water off of the roof at a prescribed rate, depending on what the project requires. And so this space beneath either pavers, vegetated roof assembly, or you can see that New York City weir-based approach, which I think has made it onto every rooftop stormwater management presentation that's ever been given, either by me or somebody else. And then passive irrigation blue roofs are similar to the detention-based blue roofs, but these actually reuse water. And so I always like to share this anecdote that here in Southern California, the city of Los Angeles and the city of Santa Monica are both under the county of Los Angeles, which has the stormwater management code. They actually interpret the code differently. And so city of Santa Monica has detention-based requirements. City of Los Angeles is more retention-based. And so as a result, we employ these passive irrigation planters on projects in the city of Los Angeles because they help meet that requirement. So again, it's about what's the requirement in the municipality, what's the requirement for the project, and then what tools can we integrate into the vegetated roof assembly to help meet that requirement. So about 45 minutes in, we're finally to successful vegetated roof coordination. Hope you're all still with us and learn a lot. Vegetated roofs, they add literally additional layers of complexity to our project. And so with that, they can bring a landscape architect into a roof space that might not, if we're just doing an exposed roof or a single ply roof that's going to be exposed, we probably wouldn't have a landscape architect involved there, or a landscape contractor, or potentially, if we're managing stormwater, a civil engineer. And so that it creates additional opportunities for coordination. So key points of coordination, really starts with the vegetated roof specifier and the manufacturer. And so I always like to ask the question, what's our objective? What are we looking to achieve here? What's our design intent? And then what can we use to help make that, to optimize that assembly, to make it efficient and ensure that it's high performing. And so there's a number of points there. The membrane specifier and the vegetated roof specifier, or the manufacturer. If they're two separate entities, what are we doing to protect the membrane from the vegetated roof assembly? Where are we transitioning from the membrane assembly, and what's incorporated into that guarantee, and what is covered under the vegetated roof guarantee? If we're talking about loading and capacity of vegetated roofs, we start involving the structural engineer in the conversation. And so understanding from the vegetated roof manufacturer, how much do these components weigh, so that we can make sure that the structure can hold the vegetated roof, and even involving the civil engineer. Are we asking the question, what are we doing for stormwater management? So
what's in your experience, what's the biggest coordination piece that's missed here?
So I'll answer that two ways. One is any place where the membrane specification stops and the overburden starts. So it could be the root barrier, it could be a drainage layer where we're stopping. If it's an inverted assembly, we're probably taking up through the insulation if we're the membrane specifier. And then maybe the landscape architect is taking everything over the top of that. But even in that case, we want to make sure that we're not just putting saturated layers on top of our extruded polystyrene. So any point where we're transitioning from, you know, somebody with the membrane specification scope in their contract, and then you know, perhaps a landscaper overburden, and then same from the contractor perspective, the membrane installer versus the landscape contractor if they're two separate entities. The other one I would say is just a missed opportunity. And again, it's ask the question, what are we doing for stormwater management early in the project? I've probably been involved in more projects than I would care to admit in the last 10, 11 years, where, you know, there was a stormwater management requirement for the project, and the team just didn't ask the question early on, and then didn't account for the inherent stormwater management properties of the vegetated roof that could have reduced maybe a detention tank in the basement and saved the owner money. And so, you know, the vegetated roof doesn't have to solve the full stormwater management picture. It just, you know, ask the question, let it contribute and give your owner some, or your client some payback for their investment. Cross-referencing specifications. This one's really straightforward. Most membrane specifiers, that's Division 7. And so vegetated roof can be in Division 7 as well, but it a lot of times is broken out into Division 32. And especially if it's a separate landscape architect involved, they'll handle vegetated roof in Division 32, just making sure especially if we're calling for a total assembly warranty or a single source, if there's a cross-reference there, so that those scopes can be clearly and appropriately bid. Of all the things, and we talk about, you know, what's maybe the biggest miss, but this is, I would implore you, most of you probably already know, you can include a pre-construction conference in your specifications. Do it. It is, I've been a part of a lot of pre-construction conferences where having everybody around the table when it comes to a vegetated roof really helps ferret out a lot of the problems that would happen. And it's a pre-construction conference before the membrane goes down, not just before the vegetated roof goes down. And so having everybody around the table able to discuss some of the project-specific coordination points is really critical to success. Leak detection. Anytime we're going to be bearing a membrane, especially beneath a vegetated roof that we're encouraging water and moisture to stay on so that the plants are viable, we want to make sure that the membrane is watertight before that overburden is placed. There's two ways that this is typically achieved. One is flood testing, and more recent, and that's gained a lot of steam over the last 10 years or so, is electronic leak detection. There are a couple of different types of leak detection, and that really, I think the biggest differentiator is it a conventional assembly where we have insulation below the membrane, or is it an inverted assembly where we have the membrane going down directly on the deck? Ultimately, you're going to want to coordinate with the membrane manufacturer as to what type of leak detection works with what type of technology or application. There are two different types of leak detection. One is a leave behind kind of consistent monitoring that's a grid probably at the lowest level, so below your tapered insulation, that will monitor and pick up any sense of moisture in the system. The other is essentially a low voltage electronic leak test to ensure water tightness just at the time of testing. So essentially it's tested, watertight, and then signed off on, and then the overburden can be placed, or if there's repairs needed, contractor will get out there and patch any leaks. So understanding guarantees, really critical. Obviously the membrane, so anything related to the roofing or waterproofing performance, how the overburden might affect that. Do we have material warranties? So are there individual components either in the vegetated roof assembly or the overburden? Are those part of like a total system warranty, or are those individually warranted? Plant warranties in the vegetated roof industry. Most manufacturers will warrant pre-vegetated mats or even plugs with a prescribed maintenance plan and follow up for 2 years. And then single source or total assembly that kind of packages it all together. The one throat to choke in the event of an issue, so that may be simplified for an owner. Plant maintenance, just like a pre-construction conference, you can include plant maintenance in your specification. I would implore you to do so. The more you can do to kind of build in at least maintenance for the establishment period of the plants, the better start that your vegetated roof is going to get, the more successful it's going to be. That first year or two is really critical to the long-term success of a vegetated roof. So bidding, clear and complete scope for bidders. We talked about that transition, making sure those coordination points are well established in the specifications and the details. And that just helps everything get off on the right foot. And then when it comes time to bid, it's very clear to say the roofing contractor what's in their scope and the landscape contractor and what's in their scope.
Hey, Rick, back to electronic leak detection or leak detection. So why a third-party leak detection versus the roofing membrane supplier?
I think third party, it would be in the roofing or the membrane manufacturer's best interest to ensure that they're providing a watertight membrane. But most membrane manufacturers don't go out and provide the testing as part of their compliance. They might have an inspection, but the testing is really introducing a third party, just like you would introduce a third party consultant for maybe observation, just as an extra step of assurance to the product.
Are most membrane manufacturers or some membrane manufacturers working in conjunction with some of these ELD companies to?
Yeah, there are coordination points, certainly for us to understand it. Like at Siplast, we make sure we're able to recommend what type of electronic leak detection with what assembly.
Thanks.
Real quick, I just want to mention that I know we're a bit over time, so just wanted to say thank you to everyone who was able to join. We can keep going for a few minutes for everyone who's able to hang on. But yeah, if any folks need to jump off, just want to say a quick thank you for joining today. Thanks,
Bo. And again, apologies for running over. I think we'll be able to wrap this up in 2 or 3 minutes.
Awesome.
So membrane installation, this is really about sequencing. Reed mentioned before, our exposure on asphaltic products is if they're not graded for UV exposure, 30, 60, 90 days, depending on the technology, making sure that the overburden contractor installing the vegetated roof is getting that covered up in a timely fashion. Is the membrane being protected? Where are materials being staged? I always like to tell contractors, especially landscape contractors, if you damage a membrane, it's not the end of the world. It's the end of the world if you damage a membrane and then you cover it up because you didn't tell anybody. Then it becomes a significant issue. So making sure that everybody's on the same page there. Installation, components, and media. Some of the components might be lightweight, drain mats. Depending on where and how the project's being sequenced, you might need to ballast those in place. Have we thought about access for getting media to the roof? There's a number of different ways you can pick super sacks with a crane. More and more common we're seeing, especially at lower elevations, I would say 6, 7 stories and below, pumping trucks that will pick up bulk media and then pump media to the roof can be a very effective means of installation. And then when it comes to vegetation, we want to make sure we have ample access to water, that the materials are, that the logistical the logistics are well coordinated so that when the material shows up on site, it's ready to be installed. We don't want to ship plant material to a project site and have it sit there and for 3-4 days and essentially become soggy lettuce. So a couple ideas to grow on here. One, I would implore you, because I'm guessing we have people from all over the country and potentially Canada, to take a look at this green roof and wall policy guide from Green Roofs for Healthy Cities. It's a great guide to learn about policy in your area that might help drive vegetated roofs or incentives, so they allow you to be a little bit better asset in terms of advocating for a vegetated roof on your project. A little self-plug here. Visit our website for additional resources, specs, details, things of that nature. Reach out to us if you have any questions about vegetated roofs specifically. And I think that gets us through. So thank you again, everybody who joined, for your time, and hope you learned a little something.
I don't know if there's any, we do have some additional questions in the chat. I don't know if we've got to get going or.
It's up to y'all. We can keep going. It does look like some folks are jumping off. We will have a record of all of the questions so that you can follow up after the event. But if there's anything that it seems like you would want to answer out loud now while we're here, feel free to read some of the more relevant ones.
I can open those now so I won't get distracted.
All right.
Jeff, I believe we actually do have the approval now for the LAs. I will make sure we follow up with you.
Thanks.
Can you use the honeycomb grids on a vegetated roof? I would need to know specifically which honeycomb. If we're talking about the one associated with purple roof, absolutely, it's intended to be used within a vegetated roof. Just would like to understand the application there a little bit. Yes, we can provide certificates for those that are not AIA. In my experience, for water detention, which is cheaper, detention at the roof, increased cost of structure, or water harvesting that pumps water back into the system? So it really, those are almost two different things. Water detention based is holding it and then releasing it off. I believe the water harvesting that's pumping it back into the system is more of a retention based technology. And so they're achieving different things. Certainly there is an implication to the structure for detention and storing water on the rooftop that needs to be figured into the cost evaluation for that application. But I don't think either one is particularly cheap. It's just going to depend on the roof, the scale, and the scope. Do I think the system is compatible with Florida hurricane zone? So, Vince, we do have some approvals for NOA for some of our paver and hardscape partners. We don't have an NOA approval for vegetated roof, but we do have some wind uplift components, and we do have some solutions that can be provided in high wind uplift areas. Anonymous said, what component of the green roof assembly has the highest failure rate? It's the plants. Can you talk about retrofitting an existing roof? The biggest issue here is typically weight. So even your thinner vegetated roof assemblies are still going to be mid-20s in terms of saturated weight. And so incorporating that additional structural loading can be the biggest challenge. But I would, again, project by project basis, kind of review it on a case by case and understand what you're looking to achieve and how we can get there. Sarah said, as a landscape architect, it is sad to hear that plant failure, but not surprised. It's just because it's the only really living component. Soil, you can make the case that soil is, or the engineered growing media is, when it's been in situ for a while, but there's just so many things that can go wrong when it comes to plants, and unfortunately. And can we obtain a copy of the presentation afterwards? We will make a version of this available after.
Awesome.
Cool.
All right, I think that gets us through all the questions. So thank you so much for everyone who joined today and everyone who hanged on for a few extra minutes to hear some of those questions out loud. And thank you, Reed and Rick, so much for an excellent presentation today. I think everyone learned a lot. I saw some nice comments that folks really appreciated it. So yeah, this was great. And I hope everyone has a great rest of their Wednesday.
Awesome.
All right.
Thanks, everyone.
Thank you.
Thanks, Bo.